We are given a function f of x in this question with this domain. We're asked to find the inverse. So I'm going to let y equal ln 2x minus 5. At the moment, I have a mapping from x to y. For the inverse, I want a mapping from y to x. Therefore, you need to make x the subject. If I just undo the logs, it must be that e to the y is equal to 2x minus 5. That's just from the definition of logs, or equivalently, you can raise both sides to the power of e. I'm nearly there. I can make x a subject. I'm going to add 5 on, and then I'm going to divide through by 2. So that is the mapping from y to x. It's just that for the inverse, we always write the inverse in terms of x, and therefore it's going to actually be e to the x plus 5 over 2. Well, the mark scheme doesn't comment on this, but technically I feel like we should just define a domain. And if we look at because it could have a restricted domain. If we look at the log function, then x has to be greater than 2.5. Well, when x is equal to 2.5, we would get ln of 0. So actually it is a bit like, it's just like the normal log function. It's just been stretched and translated, and it is going to look like that. Okay, it doesn't touch that asymptote. But what it will mean is that f of x can be any real number. And therefore, for the inverse, the domain is also any real number. So there is no restriction. We're then told we've got a function g with domain x is greater than 2. And this composite function is equal to ln x plus 10 over x minus 2. Now we need to find g of x. Well, the most systematic method is to take the inverse of both sides. So find the inverse of f of g of x, and that will equal the inverse of ln x plus 10 over x minus 2. Well, this might not look very nice, but in fact, the whole point was that I can cancel that out, and I'm just finding g of x, essentially, which is equal to the inverse of ln x plus 10 over x minus 2. I have the inverse function of x that's right above. So all I need to do is replace all my x's by x plus 10 over x minus 2. It's going to be ln. Yeah, did I say that? I can't remember, but it's going to be e to the ln x plus 10 over x minus 2 plus 5 over 2. Get on there. Obviously, I just need to simplify this. So the e and the ln cancel. I've got x plus 10 over x minus 2 plus 5 over 2. I'm going to get it over a common denominator of x minus 2. So it's going to be x plus 10 plus 5 lots of x minus 2 all over x minus 2. And this is all over 2. Now, because I'm dividing by 2, I'm essentially dividing by 2 over 1, which is the same as timesing by a half. And you can actually just put this 2 here. Okay, because I'm dividing by something and then dividing again. It's the same as just timesing the 2 and then dividing. Simplify this, so I'm going to get 6x, I'm going to get plus 10 and minus 10. And I'll just cancel out a common factor of 2 to leave me 3x over x minus 2. And we found g of x. Brilliant. Just going to, again, define a domain. X can be any real number, but x is greater than 2.